Welcome back to another episode. Today we're going to talk about membrane keypads. If you're not familiar with membrane keypads, you can just take a look at a microwave, for example, and this will give you a rough idea of what to expect. It's simply put, it's a layer of insulation, and then there are two inductive sides with two nodes, and then when you press the buttons, this pushes the copper from one side to touch the copper or whatever conductive material is on the other side. Similar to TV remote, not exactly, but that's similar. Those can be customized, so if you have a commercial design and you grab one of, let's say, off-the-shelf enclosures, plastic enclosures, and you want this to go on top, you can have it customized exactly to your needs with the graphics and the buttons and when they go. You can actually even add LEDs in there. Or you can buy, these two examples right here are available online, like Alibaba, AliExpress, eBay, everywhere basically. These are, you can find these, and they are extremely cheap. The back of these it's sticky. It's basically like a sticker. You peel the back off, and then you would have like a small slit in your enclosure or product, and you would slide the cable in, and this sits right on the surface, and then you can easily use those buttons. Now, to save on how many wires you would need coming out from the keypad, they don't have. Normally, if you don't multiplex the buttons, you would need a signal for every single button. That is way too many signals. You would have too dense of a cable, and you need too many I/Os on your system. So what they do is they multiplex the buttons, and I'll explain how that's done. The easiest way would be actually to look at the back, and over here, this cable. This is the one cable that goes to the connector, but it's actually two cables, so I'm just gonna put my finger here in between so you can see. So these are the two cables. I have 4 wires on this side and then 3 wires on the other sides. So we have 3 and 4. So if you look on this side, you would see the same thing. You would have 1, 2, 3, 4 rows and 3 columns. So this will typically match what you would have. So how does that actually work? So these wires, they are connected as it's a matrix. So you have the rows and the columns, and through the rows or the columns, you would pick which row or column you're going to be reading. So for example, I can have you would have to pick and choose. Either one is fine. Either the columns or the rows will be outputs, and the other side will be inputs. So that's how it works. Let's start with a simple example. I'm going to take those 3 and make them an outputs, and those 3 are connected to the 3 columns. You can actually see it in the back. If you have one of these and look at the back, you would see where the traces are going. So the 3 traces down there, they're going up 1, 2, the 3 columns. So I would set these 3 to outputs, and then I would set one of them to high and the rest is low. So that's the one I would be scanning. And that's the idea behind having a matrix. You are going to scan one row at a time or one column at a time if that's what you want. Again, it won't matter. You can scan it this way or scan it this way. It's the same thing. So we select the first, let's say we selected the first column. And then we go through the rows. Remember, one is outputs, one is inputs. So in this example, we decided to make the columns as outputs. So I set the 3 outputs, low, low, high. So I have 1 on this side, 0, 0 on those columns. And then through the rows, I can start checking them one at a time. Because these are, again, it's a matrix inside. So if one is high, well, if I check the first pin, and it's high, that's 1. Why is it 1? Because this is high. This is low, this is low. If I press 2 down, the inputs, I'm going to set these inputs to pull down resistors. So by default, if they're not connected to anything, they are low. So the inputs are low, and then I have 0, 0, low, low, high. So if I press 2, the first one over in the matrix, the first row, would be 0. If I press this one, it would be 0. If I press this one, it would be 1, because that's the one I selected. So then I go to the next one and read it. And next one. So in the first one, I'll be checking 1, 4, 7 star. And then I'll go back and change the column from high to low. And this one is high this time. So high, the remaining is low. Go to the next one. This is high. The other two are low. So you would just go high one at a time. And you'll be selecting that column and then scanning the rows at the same time. So the easiest and the quickest way to connect this, I was to show you a demo. I was looking at the pinout we have on, let's say, a Fez Cobra, and I noticed that these IOs are available, so I can just plug these into a keypad. I get two sets of 0.1 inch headers. I set them on a 90-degree angle and soldered them. I could have just grabbed a right angle 0.1 inch header, but the problem is those headers have really long, nice pins on one side and really short ones on the other side. The short ones are meant for soldering, not for plugging in. You couldn't really plug them in, it's just not going to make good contact. So I grabbed two sets of headers and I used put the short sides together and I had them soldered, and that's what you see over here. And now I have it connected into the circuit and connected on the other side to my keypad. Now, after I wrote the code and I tested it, it didn't actually work. And then experimenting and looking into it, seeing why I had problems with two of the rows or the columns, I can't remember. It turned out that those two pins are the I2C pins on here. They're the D2 and 3, if I remember correctly, on the Fez Cobra. The I2C pins have pull-up resistors. There is a pull-up resistor built into the system. So even though in my code I set the pin to default to pull down, internal pull down, there is an external pull-up resistor that's making the pin high again. So the solution is easy. Now we had to reverse the logic. So if you look at the source code, everything is going to seem backward. It's because I reversed if you reverse everything, then you end up with the same results. So the pins, instead of setting the pins to inputs with pull-down resistors, I set the pins to inputs with pull-up resistors, since the I2C pins are pulled up and I couldn't pull them down. Everything is now pulled up by default, and when I set the columns or the rows, when I set them, instead of saying high, low, 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 everything is low, I do it the other way around. I select using low instead of using high. If this is too confusing, I invite you to take a look at the code. I hope it would make more sense when looking at the code. But so going back to the example, instead of setting high, it's low, and then everything is high. High is not selected in this case since all logic is reversed. So here's an example. I press 1, 2, 3, A, for example, a star. So all I'm reading in this code, take a look at the code. I think it will make a lot more sense when you see the code. So you'll see in the code how we are selecting the rows or the columns, and then the other set would be the receiving end, and we will be scanning through the pins. This is also, I would like to point out that this is very similar to LED panels. If you are using an LED panel or you have seen LED panels in the past, they would not connect every single LED to a pin. They would be scanning through them. Now there is a trade-off here. It's depending on what you're trying to make. Individual pins, meaning individual controls. But if you have, let's say you have a panel that has 10 by 100 LEDs, you actually don't need 10 times 100, that's 1,000 pins. You don't need 1,000 pins to control those 1,000 LEDs. What you need is a scanner. It goes through the pins, and so those pins will be the same, those 10, and then those 100, you'll be scanning through them, and you will turning one column at once throughout the LED panel, happening quickly, and this is how, and then our eyes will see it as a full panel being on, but it's actually just one row is coming on at a time. Similar to in the keypad where we are reading one at a time. So I hope you enjoyed this video. I highly recommend you jump on eBay or your favorite store and grab one of these. Sooner or later you're gonna need it, and it's very cheap, very convenient, and you have a full keyboard. I hope you enjoyed this video, and we'll see you next week. Thank you.